We will continue with chapter 11 with recursion, and we will discuss a famous algorithm named binary search on how to do searching an array. We will do this through recursive method. So let's assume the following. We have an array, and whatever the length of the array we have, we can apply the binary search. So if we will assume that we have an array that we have 10 elements, so the location go from index 0 to index 10, and we know that the array is sorted array. So we know that the array will have elements, and elements will be from the smallest to the largest value. So for example, I will have the element 10, and then 15, and then 20, and we will continue till the end of the array. So always we have from the smallest to the largest value. Now whatever the elements you have in your array, assuming that they are sorted elements, you can apply binary search by assuming the following. You will have an index called first, and it will be the first index in your array. So in our example here will be 0. And you will have another index last, and this will be the last index of your array. So here in our example it will be 10. What I need to do then, I have to calculate a value middle, and middle should equal the value of first plus last over 2. So we will have 0 plus 10 over 2, which equals to 10 over 2, which is 5. So we will have here another variable, and this variable is called mid. So I have an index first, and this is the first index in my array. Last is the last index of my array. Mid is the middle of my array. Now I have to go and check if the value inside this middle is the value I'm looking for. So for example, let's assume I'm looking for the value as, for example, let's say 25. If we go and check and go to the array at location 5, is it having the value 25, which is the key I am looking for? If it is, then we found the key we are looking for, and we can just finish our method and we return the index, which is 5. Assume that the element inside the array at location 5 is not a 25, it's not the key I'm looking for. Assume it is a different number. So let's assume the element at location 5 is actually, for example, we have it as 10. Because the element at location 5 at the middle is 10, it means now it's not a 25, so I have to keep searching, but we have to do it in an intelligent way. Shall I go and do the searching before middle, or shall we go and do the searching after middle? Because the key 25 is greater than 10, so if it exists in the array, it will be existing after the value 10. So it will exist from location 6 up to location 10, which means now if I need to do the calculation, if I need to do the search, I should not do it from the beginning. I have to do it from location 6 to 10. And this will suggest that if the key you are looking for is greater than the value at the middle, then you have to change the value of first, and you have to move it to middle plus 1. So if middle is 5, then this one should be my first value, and again I will have to apply the same algorithm. So again I have to go and check what is the middle between 6 and 10. Is it the key I'm looking for? If it is not, do I have to search before or after? Let's assume that the value within the middle is not 10. The value within middle is actually another number. So here, for example, we are looking for 25, and here we have index 5 is 100. Because we know that the value 25 is actually less than 100, so it means if a 25 is there in my array, it will be in this space from 0 up to 4. It cannot be an index, for example, 7 or 8, because we know that all the numbers coming after 100 will be greater than 100. It cannot be 25, which means that first should be just at the same place, I shouldn't move it. I have to play with the value of last. So I have to move last. I shouldn't search up to 10. Actually, I have to search up to 4 only, which is middle minus 1. So that's why I have to have last here, which is middle minus 1. And again, we apply the same rule. Calculate middle. Is it the key? Do I have to look before or after? So the idea is, whatever the array you have, always you can apply binary search if it is a sorted array. We cannot apply binary search on an array that is not sorted, otherwise it will not work in this case. And always it will say that you have two numbers, the first index of your array and the last index of your array, which means I'm looking from first to the last. I'm looking from the beginning till the end. Now I will go and check the middle value by going and calculating first plus last over 2. So we will end up with another variable, and this is as middle. Now I have three cases. Either the element at middle is the key I'm looking for, is the value I'm looking for, so I am done. Otherwise, it could be before or after. So it could be in this space, which means that the key I'm looking for is greater than the name of my array, for example, list at location middle. Or it could be before, which means the key I'm looking for is smaller than the array at location middle. If either cases, it means we have to play with the first and last. If we have the case that the key is actually smaller than, it means first should not be changed, but we have to change the boundary of the last. So last should be moved to middle minus 1. If it is the case that is actually greater than, it means last should be unchanged. All what I have to do is, I have to move first to middle plus 1. And then we will continue with this one. So if we just put it down here, in this case, I will have to say that the value of first shouldn't be 0. It should be actually middle plus 1. And then continue your search. And if it is smaller than, then the value of last should not be 10. It should be 4, which is middle minus 1. And then again repeat the process here, again repeat the process till you find your middle. So the coding it will be, or let's have a look here at the example with numbers. So let's assume I'm looking for 33 and I'm having the following. I'm having 0 as the first index, as 9 as the last index. So I'm having here first as 0 and I have last as 9. And we have numbers. We have 5, 7, 9, 13, 32, 33, 42, 54, 56, 88. So all the numbers are sorted from the smallest to the largest value. Now step number 1, calculate middle. So middle should be 0 plus 9 over 2, and this will give us 9 over 2, and this will give us as 4. So remember, integer over integer is 4. So it means middle will be as 4. Now you have to go and check the element at middle. Is it the key you are looking for? 32, is it the key, which is 33? It's not, which means I didn't find my element, but I have to continue searching. Now I have to ask myself, now 33 should be coming before 32 or should be coming after the middle we found? So I'm looking at this one. Shall I search before or shall we search after? Now because 33 is greater than 32, it means we have to search after. So what does it mean? It means I have to go to first and I have to say first should not be 0, actually first should be 5. So that's why I'm saying you have to go and change the value of first to be 5. So here you will notice that we will do the following. 5 will be the value of first and 9 is still the same thing, still as 9. Again, go and calculate middle. So we will calculate middle. 5 plus 9 over 2, which will give us 7. So middle is 7. Again, I have to ask myself, is it the key I'm looking for? Go to middle, which is 54. Is it equal to the key 33? It's not. Do I have to search before or after? If I have 33, will it be before 54 or after 54? Now we know because 33 is smaller than 54, so always if I find it, it will be before that, and that's why it means last should not be 9. Actually, last should be coming before, so last should be as 6. So here you will notice that 5 will be first and 6 will be last. And when you come and you calculate middle, 5 plus 6 over 2 will give you 5. So again, middle will be having the same value as first. Now you need to check the element at middle 33. Is it the key you are looking for? Yes. So here you have to stop and you have to say yes, we found the element at location 5. Now this is if the element exists in your array. You will find it much quicker than going with sequential search from the beginning till the end, where you are just breaking down your array. Now if the element I'm looking for is not there, what is the condition that it will stop us? Here we have to notice that, for example, in the first example here, the value of first is 0, last is 9, so 0 is less than 9. The second one we have 5 and 9, 5 is also less than 9, 5 and 6 also 5 less than 6. So if you go to the previous example, always the value of first should be less than last or equal. If you come across a situation like this, you are looking for all the elements from the beginning and from the elements till the end, and then you have an overlap such that you reach a case where the value of first is not smaller than, is greater than the value of last. It means you finish searching for your elements in the array and the element is not there. So you have to stop and you have to return -1. The meaning of -1 is we finished searching our array and we couldn't find the key you are looking for, so we will stop and we will return -1. So the coding will work as follows. If the value of first is greater than last, return -1. This is just like as we explained now. If the value of the first boundary is greater than the last boundary, it means we finish searching and then we will return -1. Otherwise, the procedure is first calculate middle as first plus last over 2. If the target, this is the key you are looking for, equals A at middle, the name of the array at middle, then you will have to return middle. If you are looking for 33 and at middle there is 33 at location 5, which is middle, so you just return middle. Otherwise, you have to check, do I have to search before or do I have to search after? So if the target is smaller than, it means now what I have to do, I have to change the value of last. It should be mid -1. So that's why I will say call the method again, send the array as it is, send the key as it is. First should be changed, should not be changed, but the value of last should be mid -1. In the last case, if the target, if the value we're looking for is greater than the array at location middle, so it means here I will change the value of first, so it should be middle +1. So if we will draw it together, it means they are talking that assume your array is called A, assume the element you are looking for is called target, so whatever the element I'm looking for, and I will have first and last, so always first will be my first index, which is at the beginning 0, and last will be the last index, whatever the number is. Now, if we are still within the boundaries, first is smaller than the last, then this is okay. If we just have first greater than last, then we will stop. Calculate middle. So go and calculate the value of middle, and this will be one of the elements in your array. Now go and check if the target equals A of middle. If the target is 10 and the A at middle is 10, then this is fine. You have to return only the location middle. So if middle is 5, just return the middle, which is 5. Otherwise, if the value is not the same as the target, you have to search before or after. So if the target is smaller than A of middle, so if the target is 10, but the location 5, we have a value which is 50. So it means now when I do search, I will take the same array, the target will not be changed, first will not be changed because I have to search here, which means first should not be changed. I have to change last, I have to bring it before, so I have to bring it middle minus 1. That's why here we say middle minus 1. So middle minus 1 will go to the last. So when you call your method again, last will take the value of middle minus 1. The last case, if target is greater than A of middle, if the target you are looking for is 100 and you have 50 as your middle, so it means 100 will be existing after the target. So what does it mean? It means last you should keep it, you should not change last, but you should change first to be middle plus 1. So keep the array as it is, keep the target as it is, change first because here the value of first, I have to change it to middle minus 1. So middle minus 1 will be my first, but last keep it as it is. So I will not do a change. So here, if we will check how many base cases we have and how many general cases, I have, this is a base case, because if we cannot find the element, we will simply return minus 1. And this is also a base case, because if you find your element, you will return the location. We have two general cases, if it is coming before or after the middle. So these two are general cases. I have to call the method. I will send my array and the target I'm looking for. I just have to play with one of the indices. Either I have to change the value of first, or either I have to change the value of last. And by this one, I'm changing the value of last, and in the last one, I'm changing the value of first. Please refer to the file binarysearch.java that you have on Teams. Try to input different arrays, but always remember your array should be sorted array. And execute the array, execute binary search. Try sometimes elements that is not found in the array, so you will return minus 1. And sometimes enter elements that is at the middle, before or after middle, just to know how does it run and how the execution is happening.